Imagine being able to traverse planets, stars, and galaxies with nothing to stop you. This is how the universe is seen by a neutrino, an almost invisible particle that crosses everything unnoticed. This audiobook invites you to explore the cosmos from that impossible and silent perspective, revealing a reality hidden beneath the surface of the space we know, a journey through the invisible, where everything changes in scale, shape, and meaning. Neutrinos are subatomic particles much smaller than atoms, and possess properties that make them unique. Unlike other particles, such as electrons or protons, neutrinos hardly interact with matter. Imagine a tennis ball passing through a wall without leaving a trace. That's how neutrinos move through the universe. They are like ghosts that pass through everything without being seen or felt. But what does this mean for us? In the universe, neutrinos are generated in enormous quantities. For example, every second, trillions of neutrinos pass through your body without you noticing. They come from various sources such as the sun, supernova explosions, and even from our own planet. But why are they so important? The answer lies in their ability to provide us with valuable information about cosmic processes that would otherwise be invisible. Imagine that neutrinos are like the footprints left by an animal in the forest. Although you can't see the animal, its footprints can tell you where it has been and what it has been doing. Similarly, neutrinos provide us with clues about distant cosmic events and phenomena that we cannot directly observe. They help us unravel the secrets of the cosmos, from nuclear fusion at the heart of the sun to the violent explosions of supernovae. The story of neutrinos is as intriguing as the particles themselves. Their existence was theorized in 1931 by physicist Wolfgang Pauli, who sought to explain a mystery in nuclear physics. However, it wasn't until 1956 that they were first detected in an experiment. Imagine the excitement of scientists realizing they were on the brink of a new discovery that would change our understanding of the universe. Since that first discovery, interest in neutrinos has grown exponentially. There have been numerous experiments and studies, each revealing more about their nature and behavior. But understanding neutrinos is not just a matter of scientific curiosity. It also has profound implications in particle physics and our understanding of matter and energy in the universe. Why are neutrinos so difficult to detect? The answer is simple. Their lack of electric charge and their weak interaction with matter make them true ninjas of the subatomic world. They can pass through planets without being stopped, making their detection a monumental challenge. However, science has found ingenious ways to capture them, using enormous detectors filled with water or ice, where neutrinos leave a small but detectable signal when interacting with other particles. Through these interactions, scientists have learned that neutrinos exist in 3 flavors: electron, muon, and tau. This variety is essential for understanding their behavior, especially when considering the fascinating idea of neutrino oscillations, where they can change from one flavor to another as they travel through space. This property has opened new doors in the field of physics research. The importance of neutrinos extends beyond particle physics. They influence cosmology, dark matter, and, intriguingly, the possible existence of life in other corners of the universe. The search for answers about neutrinos could even help us unveil some of the deepest mysteries of existence itself. As we delve deeper into the study of neutrinos, we are at the frontier of a research field that promises to transform our understanding of the universe. Each discovery about these particles brings us one step closer to solving questions that have puzzled scientists for centuries. By exploring the world of neutrinos, we are not only unraveling their secrets, but also opening new avenues of thought about the reality that surrounds us. Research in this field is a reminder of how vast and amazing the universe is, and how many wonders we still have left to discover. In the upcoming sections, we will delve into each of these aspects, revealing the history, science, and magic of neutrinos. So get ready for a fascinating journey where every question we answer only leads to new questions to explore. Welcome to the adventure of knowledge, where neutrinos are our guides on the path to understanding the cosmos. Neutrinos are fascinating particles, but what exactly are they? Imagine you are at a party full of people with music blaring and flashing lights. In the midst of that noise, there is someone moving through the crowd unnoticed, almost as if they weren't there. That's what neutrinos are in the vast universe, almost invisible particles that pass by us without us realizing. To better understand these elusive cosmic travelers, we must know that they are subatomic particles, much smaller than a proton or an electron. In fact, they are so tiny that if we had a neutrino in the palm of our hand, we couldn't see it even with the most powerful microscope. It's amazing to think about. Despite their size, neutrinos are incredibly abundant. It is estimated that billions of them pass through every square centimeter of our body every second, yet they barely interact with matter. Neutrinos were first proposed in 1930 as a solution to a problem in nuclear physics. When nuclear reactions occur, such as those happening in the sun, it seems that something is missing from the equation. That missing part is due to the existence of neutrinos, which carry away a portion of the energy that cannot be seen. It's like in a game of chess, where a piece is moving without anyone seeing it, yet still affecting the outcome of the game. One of the most intriguing characteristics of neutrinos is that they have an extremely small mass. In fact, it is so light that for a long time it was thought they were massless particles. Despite their lightness, neutrinos are fundamental in the universe. They are produced in a variety of cosmic processes, from reactions in the hearts of stars to supernova explosions. Every time a star burns, it releases a torrent of neutrinos, as if it were sending signals into space, communicating with the universe. But what does this mean for us? Why should we care about these invisible particles? Neutrinos are like messengers from the cosmos. They tell us stories about what is happening in distant and unknown places, giving us clues about the formation of stars and galaxies. Every neutrino that passes through the Earth is a window into the secrets of the universe, revealing details about phenomena that would otherwise remain hidden. One of the most surprising things is that, unlike other subatomic particles, neutrinos can pass through matter almost effortlessly. They can go through entire planets without colliding with anything. Imagine throwing a tennis ball through a brick wall. Usually the ball would stop, but a neutrino could pass through that wall without it noticing. This property makes them extremely intriguing particles for scientific research. Neutrinos come in 3 flavors: electron, muon, and tau. Each of these flavors has its own characteristics, but the most interesting thing is that neutrinos can change from one flavor to another. This phenomenon is called neutrino oscillation and has intrigued scientists for years. It's like being at a party and suddenly the person you thought was a friend transforms into someone completely different. This ability to change indicates that there is much more to them than meets the eye. Moreover, neutrinos are fundamental in the study of particle physics. Although they are difficult to detect, studying them helps us better understand the fundamental forces that govern our universe. This includes how particles interact with each other and how they behave under different conditions. Undoubtedly, their elusive nature has challenged scientists to think creatively and develop new technologies to detect them. Throughout the history of science, neutrinos have become a symbol of the mysteries of the universe. Despite their omnipresence, they remain an enigma. Every discovery related to them opens up new questions and challenges. It's as if every answer we find leads us to a new maze filled with more questions. Neutrinos also allow us to glimpse cosmic events that are beyond our current understanding. From the Big Bang to the formation of black holes, these particles are some of the keys that will help us unravel the secrets of the cosmos. Research on neutrinos is, in many ways, a quest for our own place in the universe. The science behind neutrinos is complex, but their impact on our understanding of the cosmos is undeniable. As scientists continue to explore their nature and properties, a new world of possibilities and discoveries opens up. In a universe where so much remains unanswered, neutrinos are a reminder that there is much more to discover, and that every small advance brings us one step closer to understanding the vastness of the cosmos. So what does the future hold for neutrino research? Every discovery brings us closer to the very essence of the universe. Human curiosity drives us to keep seeking answers, and in that quest, neutrinos are essential companions on our journey into the unknown. If you're enjoying this journey through the universe and want to keep exploring more cosmic mysteries, don't forget to subscribe to the channel and give the video a like. Thank you for being part of this Star Odyssey. The story of the discovery of neutrinos is like an exciting journey through human curiosity and the quest for knowledge. It all began in 1931 when a physicist named Wolfgang Pauli proposed an idea that would change the course of physics. Pauli, observing the mysteries of radioactivity, realized that something was missing from the equation. He faced a dilemma. In certain nuclear processes, it seemed that energy was disappearing like a magic trick. Where was it going? His answer was the proposal of a new particle, which he named neutrino, that would be so elusive it could pass through the planet without leaving a trace. Imagine a fish swimming in the ocean that, despite millions of eyes watching it, can go unnoticed. This is how Pauli thought the neutrino would be, a particle so light and small that it would be almost impossible to detect. But how can you prove the existence of something that is so hard to see? This is where the story becomes fascinating. Nearly 2 decades passed before Pauli's idea became a reality. In 1942, a group of scientists led by American physicist Clyde Cowan and his colleague Frederick Rhines embarked on a bold experiment. They set out to detect these elusive neutrinos using a source of antineutrinos generated by a nuclear reactor. Imagine a lighthouse emitting light in the darkness, and the researchers were there, waiting for the light of the neutrinos to illuminate their path. The task was not easy. Neutrinos, being so non-interactive, are like ghosts that can pass through walls and mountains without being stopped. However, Cowan and Rhines employed an ingenious trick. They built a detector in a strategic location, with large amounts of water and a bit of radioactive material, creating an environment where neutrinos could, on rare occasions, interact. In the end, their perseverance paid off, and in 1944 they announced to the world that they had detected neutrinos for the first time. It was a monumental triumph. This discovery not only validated Pauli's hypothesis, but also opened a new chapter in physics. Neutrinos became key pieces of the puzzle of the universe, and their existence began to be increasingly relevant. But why are they so important? As scientists explored neutrinos, they realized they were involved in fundamental processes, from nuclear reactions in the sun to supernova explosions. Over time, neutrinos began to take center stage in their own story. In 1973, another important discovery took place: the observation of solar neutrinos. Scientists realized that the sun was not only our king star but also a factory of neutrinos. This raised intriguing questions about energy production at the heart of the sun and how neutrinos could provide clues about what happens inside it. The more researchers delved into the world of neutrinos, the more mysteries were revealed. In 1998, an experiment in Japan called Super Kamiokande showed that neutrinos could change from one type to another, a phenomenon known as neutrino oscillation. This finding was a game changer. It not only confirmed that neutrinos existed, but also that they had mass, something thought impossible at their initial discovery. The idea that such a light particle could have mass was like discovering that a small bird could lift a heavy tree. The story of neutrinos remains an exciting journey, full of discoveries and unanswered questions. For example, what role do they play in the dark matter that makes up much of the universe? As scientists continue to investigate, each new finding about neutrinos raises more questions, demonstrating that our understanding of the universe is far from complete. Neutrinos have not only changed our understanding of physics, but have also inspired a new generation of scientists. The curiosity that drove Pauli, Cowan and Rhines is still alive in today's laboratories. Every experiment, every observation is a small step toward understanding the secrets of the cosmos. Thus, the story of the discovery of neutrinos is a reminder of what it means to be human, the constant search for knowledge and the courage to question what we think we know. In this journey, neutrinos show us that although they are invisible, their influence on the universe is profoundly real. Who knows what else we will discover about these particles in the future? The story is just beginning. Neutrinos, those small, almost ghostly particles, play a fundamental role in the structure of the universe as we know it. But what is their place in the standard model of particle physics? To understand this, we first need to unravel what the standard model is. Imagine we are at a party where there are different groups of people. Some are close friends, while others barely know each other. At this party, neutrinos are those guests who, although present, are difficult to detect and do not interact with others in the same way that others do. The standard model is like the guest list for this cosmic party. It includes well-known particles, such as electrons and quarks, which are the building blocks of matter. Neutrinos, on the other hand, are somewhat like distant cousins who only show up occasionally and when they do, barely make their presence known. This is due to their extremely light nature and minimal interaction with other particles. Therefore, although they are abundant in the universe, they go unnoticed in our daily lives. But why are neutrinos so important? Despite being almost undetectable, these tiny messengers have a significant impact on the interactions that occur in the cosmos. In the standard model, neutrinos are part of a family of particles called leptons, which also includes electrons and their heavier siblings such as muons and taus. This family is essential for understanding how matter behaves at the subatomic level. Whenever we think of fundamental forces, such as gravity or electromagnetism, we might imagine that neutrinos are the silent travelers gliding through interactions. In this model, neutrinos are responsible for processes like beta decay, a phenomenon that occurs in many types of nuclear reactions. This means that, although we do not see them, their influence is constantly present in the transformation of particles. Another intriguing question is, how are neutrinos produced in the universe? The answer is fascinating. They originate from various cosmic processes, from nuclear reactions at the heart of stars to the cataclysmic explosions of supernovae. So every time we look at the sky, we might be witnessing a cosmic fireworks display where neutrinos are the tiny flashes escaping the scene unnoticed. In the context of the standard model, neutrinos have a special relationship with the fundamental forces. They are involved in the weak interaction, one of the four forces that govern the universe. This interaction is responsible for processes like particle decay and nuclear fusion in the Sun. So, although they are subtle, neutrinos are at the heart of some of the most astonishing phenomena in the universe. One of the most interesting features of neutrinos is that they come in three flavors: the electron neutrino, the muon neutrino, and the tau neutrino. These names come from the leptons with which they are related. It's similar to having three types of ice cream at an ice cream shop. Each has its own flavor, but all are equally delicious in their own way. Can you imagine being able to taste a neutrino? Maybe not, but their diversity is essential for understanding how they interact with each other and with other particles. However, despite their importance, neutrinos are elusive. In a universe filled with particles, these tiny messengers are like shadows gliding through matter without leaving a trace. This raises a fascinating question. How can we study something that is so difficult to detect? Despite their elusive nature, scientists have developed ingenious techniques to capture the presence of neutrinos using large detectors underground or in the ice of Antarctica. These facilities resemble enormous traps designed to catch these cosmic travelers. One of the reasons neutrinos are so intriguing is that despite their weak interaction, they can provide valuable information about distant cosmic events. For example, when a star explodes in a supernova, it emits a large number of neutrinos that can travel through space and reach Earth. These neutrinos are like distress signals from a dying star, and by detecting them, scientists can learn about the process that led to the explosion. So, what role do neutrinos play in the grand scheme of the universe? As part of the standard model, their existence helps fill the gaps in our understanding of matter and energy. Without them, many of the theories that underpin modern physics would remain incomplete. They are like pieces of a cosmic puzzle that, although small and invisible, are essential for seeing the complete picture. With each discovery about neutrinos, scientists get a little closer to unraveling the mysteries of the universe. As we progress on our journey through the cosmos, it is crucial to remember that even the tiniest particles can have a monumental impact. With each new research endeavor, we find ourselves one step closer to answering questions that have fascinated humanity for centuries. In summary, neutrinos are not just particles, they are messengers of the universe, traveling through time and space, carrying secrets that we are still trying to decipher. Their presence in the standard model of particle physics is a reminder that sometimes the smallest things can have the greatest impact. As we continue to explore this fascinating world, neutrinos will remain an intriguing subject of study, challenging us to look beyond the visible and question what we really know about the universe. When we look at the sky, the sun shines brightly, but behind that light lies a fascinating phenomenon occurring in its core: the production of neutrinos. Neutrinos are extremely elusive particles, and their origin is deeply linked to the nuclear reactions that fuel our star. But what does this really mean? To understand it, we must first delve into the heart of the sun. In the solar core, temperatures exceed 15 million degrees Celsius. In that extreme environment, hydrogen atoms fuse to form helium, releasing a tremendous amount of energy in the process. This is the same phenomenon that occurs in a hydrogen bomb, but on a controlled and stable scale that allows life to flourish on Earth. However, during these reactions, not only is energy released, neutrinos are also generated. But why are they important? Imagine that neutrinos are like tiny messengers escaping from the sun. Unlike other particles that can be absorbed or deflected by matter, neutrinos are so light and weakly interactive that they can pass through anything. In fact, billions of neutrinos from the sun pass through your body every second without you noticing. Isn't it amazing to think that you are surrounded by these invisible particles? Now the question is, how many neutrinos are generated in the sun? It is estimated that every second, the sun produces more than 1 trillion neutrinos per square centimeter. This means that as you look at the sky, you and everything around you are being bombarded by these tiny cosmic messengers. But how do we know they exist? This is where science comes into play. Despite being so elusive, scientists have developed ingenious techniques to detect neutrinos. In a famous experiment, a tank filled with water and a very sensitive sensor system were used. When a neutrino interacts with a water atom, it can produce a small signal of light. Although this signal is extremely weak and can be difficult to detect, it is enough for scientists to confirm the presence of these elusive messengers. Isn't it impressive how something so small can have such a significant impact on our understanding of the universe? The neutrinos generated in the sun not only tell us about the energy produced by our star, they also provide crucial information about the nuclear fusion process. By studying these neutrinos, scientists can learn more about how the sun converts hydrogen into helium, which in turn helps us understand the evolution of other stars in the universe. But what else might they be telling us? Solar neutrinos also play an important role in astrophysics. Through their study, researchers can explore how processes in the sun affect Earth. For example, during extreme solar events, such as solar flares, the number of neutrinos reaching our planet can vary. Analyzing these fluctuations can help us predict phenomena like geomagnetic storms, which can affect our communications and navigation systems. However, there is an even more intriguing aspect. Neutrinos can also provide clues about the history of our solar system. When the sun formed, it was not alone. It was surrounded by a cloud of gas and dust. By studying the neutrinos generated in its core, scientists can gain insights into the composition and conditions of that primordial cloud. This helps us understand how not only the sun formed, but also the planets that orbit around it. So is there anything we don't know about solar neutrinos? The answer is yes. There are still many unanswered questions. For example, scientists are investigating whether there are different types of neutrinos produced in the sun. and how those types might influence the way they interact with matter. Each new discovery opens the door to more questions. What secrets will they reveal to us in the future? As technology advances, our methods for detecting and studying neutrinos also improve. New experiments are underway, and they are expected to provide deeper insights into how the sun generates these messengers. Research in this field is not only exciting but could also have broader implications for our understanding of the universe. Let's think about this. If solar neutrinos are like small messengers coming from our sun, then they are also a reminder of how interconnected everything is in the cosmos. The study of these particles not only helps us understand our star, but also offers us a window into the very nature of matter and energy in the universe. So, the next time you admire the light of the sun, remember that behind that light is a world of invisible particles telling a fascinating story. Neutrinos, though small and elusive, are giants in the realm of science and provide us with the opportunity to unravel the mysteries of our universe. Who knows what other secrets await discovery in the bright yet enigmatic world of neutrinos? What happens during a supernova explosion? It is a cosmic spectacle that can shine brighter than an entire galaxy for a short period of time. But did you know that in this process, neutrinos play a fundamental role? These mysterious messengers of the universe are produced in massive quantities in the heart of a supernova, and their study offers us valuable clues about these cataclysmic events. Supernovae are the result of the death of massive stars. And when one of these stars collapses, an unimaginable release of energy occurs. In this chaos, enormous amounts of neutrinos are generated, which are almost undetectable and escape from the star in an instant. But why are these neutrinos so important in the context of a supernova? The answer lies in their ability to pass through matter with hardly any interaction, unlike light, which can be absorbed or scattered. Neutrinos can travel through light years of matter, meaning they can leave the supernova and reach Earth, telling us secrets about what happened at that critical moment. Imagine a room full of people shouting and making noise. In the midst of all that commotion, someone whispers an important message. That is the nature of neutrinos. Amidst the roar of a supernova explosion, they are the whisper that reaches us through the noise of the universe. But what exactly do they tell us? They provide information about the amount of energy released during the explosion and about the nuclear processes occurring inside the star at the moment of its death. Neutrinos are like a kind of cosmic diary that documents the moment of stellar collapse. When a massive star reaches the end of its life, its core compresses and the temperature and pressure become so extreme that nuclear reactions occur, producing these elusive particles. This is where the real spectacle begins. In a matter of seconds, trillions of neutrinos are produced, and it is in that explosion where one of the keys to understanding the physics of stars and the formation of heavy elements in the universe can be found. But how do we know that these neutrinos actually come from supernovae? The answer lies in the recent history of astronomy. In 1987, a supernova known as SN 1987A exploded in the Large Magellanic Cloud. And during that event, neutrinos were detected in an experiment called Kamiokande 2 in Japan. It was the first time that scientists were able to directly observe the manifestation of these cosmic messengers. This discovery was a milestone, as it confirmed that neutrinos were produced in large quantities during supernova explosions. The importance of neutrinos does not stop there. By studying how these space travelers affect their surroundings, scientists can gain details about the distribution of matter in the universe. When neutrinos interact with matter, even though they do so rarely, they can provide information about the density and composition of matter in the places where they are generated. In fact, it is believed that the way neutrinos scatter as they leave a supernova may help explain the asymmetry we see in the universe, such as the predominance of matter over antimatter. Some might wonder, why should we care about these distant cosmic events? The answer is that supernovae and neutrinos teach us about the evolution of the universe and the formation of the elements that make up everything we know. including our own planet and the life that exists on it. Understanding how stars are formed and destroyed gives us a broader view of our place in the cosmos. At its core, the study of neutrinos in supernovae reflects our innate curiosity to uncover the mysteries of the universe. Every neutrino that is detected is a small piece of information that connects us to those events that occurred thousands of light years ago. It is like receiving a letter from the past, where every word is filled with secrets about the workings of the cosmos. As technology advances, scientists are developing new methods to detect and study neutrinos from supernovae. This includes telescopes specifically designed to capture these particles. The next time a supernova explodes, researchers will be better equipped to understand not only the explosion itself, but also the impact it had on the cosmos. Neutrinos in supernovae are, in a sense, like the fingerprints of the universe. Each explosion leaves its unique mark, and studying these patterns can help scientists untangle the complexity of stellar physics. But there are still many mysteries to solve. What else can they teach us about the forces that shape our universe? The questions are endless, but one thing is certain: neutrinos will continue to be a key piece in our cosmic puzzle. By studying their role in supernovae, we are not only exploring the end of stars, but also the beginning of life and matter as we know it. So the next time you look up at the sky and see those bright stars, remember that behind their light lies a world of neutrinos waiting to be discovered. Neutrinos are some of the most fascinating and mysterious particles in the universe, and one of their most intriguing characteristics is that they come from a variety of cosmic sources. But where do these tiny messengers of the cosmos actually come from? To answer that question, it is essential to explore some of the most enigmatic sources that generate them. Let's start with black holes. These cosmic entities, which form when a star collapses, are capable of trapping everything around them. Not even light can escape their gravitational pull. However, despite their dark nature, black holes are known to emit a large number of neutrinos, especially when they devour matter. Imagine a kind of voracious stomach that, while eating, not only feeds but also spits particles into space. When matter falls into a black hole, it heats up and accelerates, generating a shower of neutrinos that travel through the universe at speeds close to the speed of light. Gamma-ray bursts represent another impressive source of neutrinos. These explosions are some of the most energetic events in the universe and occur when a massive star collapses or when two neutron stars collide. During these catastrophes, unimaginable amounts of energy are released, resulting in enormous flows of neutrinos. These particles, despite being practically undetectable, offer us clues about these extreme cosmic events. It's as if these neutrinos are the fingerprints that allow us to trace the history of an explosion that occurred billions of light years away. But what about supernovae? When a star reaches the end of its life, a spectacular explosion occurs, and in this process, enormous amounts of neutrinos are also generated. In fact, it is estimated that during a supernova, more neutrinos can be released in a few seconds than the Sun will emit in its entire lifetime. Imagine that every time a star dies, it sends a signal in the form of neutrinos that travel through space, passing through planets, stars, and galaxies until they reach us. That is why neutrinos are considered messengers of the universe. They tell us stories of distant and powerful events. Another interesting source of neutrinos is Type II supernova explosions, which occur when a massive star exhausts its nuclear fuel and its core collapses. This collapse generates a shock wave that expels the outer layers of the star into space. During this process, trillions of neutrinos are released in the blink of an eye. So every time we observe the remnants of a supernova, we are actually seeing the echo of those neutrinos traveling through the cosmos. Active galactic nuclei, which are extremely bright regions at the center of some galaxies, are also dazzling sources of neutrinos. These nuclei contain supermassive black holes that attract matter around them. And when this matter accelerates and heats up, neutrinos are generated. It's as if these black holes are cosmic beacons, emitting signals in the form of neutrinos as they devour the material surrounding them. The interaction between high-energy particles such as protons and cosmic radiation also produces neutrinos. When protons collide with other particles in space, they can generate neutrinos, meaning that even the cosmic background is filled with these elusive particles. It's as if the universe is constantly speaking through neutrinos, sending messages about its nature and the events occurring within it. As we explore more about neutrinos, we find that even collisions in our own solar system, such as those occurring between high-energy particles, generate neutrinos. This means that we don't only have to look into deep space to study these particles, we can also find them here in our cosmic neighborhood. Imagine that every time we look at the sky, we are surrounded by a constant rain of these tiny particles that tell us stories about the universe. The search for neutrinos is not limited to distant sources. They have also been detected in our oceans and in the ice of Antarctica, where experiments aim to capture these elusive messengers. The ability to detect neutrinos opens a window to phenomena that were previously invisible to our eyes. Thus, as we continue to unravel the secrets of neutrinos, a broader picture of the structure and functioning of the cosmos is revealed. Neutrinos are not only fascinating because of their origin, but also because of their nature. Despite being incredibly abundant, they interact very weakly with matter. This means they can pass through the Earth as if it were air, making them the ghosts of the universe. This property allows astronomers to study events that would otherwise be impossible to observe. As we continue to explore the cosmic sources of neutrinos, it is important to remember that each tiny flash of these messengers can provide a piece of the puzzle of the universe. By understanding where they come from and how they are produced, we can begin to decipher the mysteries of the creation and evolution of the cosmos. Neutrinos, despite their tiny size, play a fundamental role in our understanding of the universe, and their study will lead us to even more exciting adventures in the future. Neutrinos are like ghosts in the world of particles. They are so small and light that they can pass through matter almost unnoticed. In fact, millions of them are passing through you at this very moment. But what does this mean exactly? How can these elusive particles travel undetected, and why should we care? Imagine a sunny day in a park. You are enjoying the fresh air and tranquility, and suddenly you feel a light breeze passing by you. You don't see it, but you feel its presence. Neutrinos are that breeze in the vast universe. They are generated in processes like nuclear reactions in the sun, and like the wind, they move through space and matter without being stopped. This raises a fascinating question. How is it possible for these tiny particles to pass through the Earth without being blocked? The answer lies in their nature. Neutrinos are incredibly small, so much so that their mass is almost insignificant compared to other particles. This means they can pass through atoms and molecules as if nothing. To put it in perspective, if a neutrino were the size of a golf ball, the nucleus of an atom would be the size of a city. This comparison helps us understand why, despite trillions of neutrinos passing through us daily, we do not feel them, and for the most part, do not detect them. What happens when a neutrino finally interacts with matter? The truth is that these interactions are extremely rare. When a neutrino encounters an atomic nucleus, the probability of it interacting is so low that it's practically like winning the lottery. However, when this interaction occurs, it can release a significant amount of energy. This is what scientists look for when trying to detect neutrinos. Those rare moments when a neutrino decides to collide with something. Neutrinos not only pass through the Earth, but they can also be produced on our planet. For example, when cosmic rays collide with the Earth's atmosphere, neutrinos are generated. These neutrinos can travel through the Earth and emerge on the other side, once again demonstrating their ability to pass through matter almost effortlessly. But why is this production of neutrinos in our own cosmic home important? Scientists use neutrino detectors to explore these interactions. Some of these detectors are located in large underground tunnels or even at the bottom of frozen lakes. Can you imagine being in such a remote and dark place, waiting for a neutrino which could have traveled thousands of light years to finally decide to interact with you? This is exactly what researchers do in their quest to understand the nature of these mysterious particles. The detection of neutrinos is based on the idea that, although they are difficult to catch, they can leave a trace when they interact. For example, in an ice detector, when a neutrino collides with a water atom, it can generate a flash of light that scientists can measure. Thus, through these rare interactions, we can learn more about the universe and how particles within it function. Every time a neutrino passes through the Earth, it is telling us a secret about the cosmos. These secrets may include information about distant cosmic events such as supernova explosions or black hole activity. By studying the neutrinos that reach our planet, scientists can gain insights into phenomena that would otherwise be invisible and unreachable. Now, there is an intriguing question that arises. Could we be surrounded by neutrinos and not even realize it? The answer is a resounding yes. Neutrinos are often considered the messengers of the universe, as they can travel vast distances without being altered. This means that despite being surrounded by them, we are unaware of their presence. But what if we could see these neutrinos? How would that change our understanding of the world? As we explore the interaction of neutrinos with matter, we also encounter a fascinating dilemma. If they are so abundant and light, why don't we see them more often? The answer lies in their elusive nature and the need for advanced technologies to detect them. The development of neutrino detectors has been a huge challenge, but also an exciting journey that has led to many discoveries. In summary, neutrinos are some of the most intriguing particles in the universe. Their ability to pass through matter and their almost ghostly nature offer us a unique window into the unknown. They show us that, although we may not always see something, that doesn't mean it isn't there. Every day, as we go about our lives, these tiny messengers of the cosmos whisper secrets about the universe to us. And only through science can we attempt to understand what they have to tell us. So the next time you feel a gentle breeze or find yourself surrounded by silence, remember that there is an invisible world around you. A world full of neutrinos that, like the wind, is in constant motion, guiding us through the mysteries of the universe. Did you know that neutrinos are like ghosts that pass through everything around them? These subatomic particles are so elusive that they could travel through the Earth without leaving a trace. But what makes these particles so special and difficult to detect? The answer to this takes us to explore how they interact with matter on our planet. Neutrinos are extremely light particles, and unlike other types of particles, they have a very weak interaction with matter. This means that in most cases they can pass through the Earth without colliding with anything. To put it in perspective, imagine throwing a tennis ball through a mountain. The probability of the ball hitting something on its way is almost zero. That's how rare neutrino encounters with matter are. So how do we know they exist if they are so hard to catch? The key lies in experiments specifically designed to detect these particles. One of the most impressive methods takes place in unusual locations, such as the perpetual ice of Antarctica. Here, scientists have built facilities that allow them to observe the flashes of light produced when a neutrino, upon finally interacting with a water molecule, creates a small shower of charged particles. This gives us a hint of the existence of neutrinos. But ice is not the only hunting ground for neutrinos. There are also underground experiments where large tanks filled with water or other liquids are used. In these controlled environments, neutrinos can trigger reactions that can be measured. Imagine a group of friends playing hide and seek in a huge basement, only instead of looking for each other, they are waiting for a neutrino to show up. The techniques for detecting neutrinos have advanced by leaps and bounds. In some cases, scientists use extremely sensitive sensors to capture the tiny signals they produce. It's like trying to hear a whisper in a room full of people shouting. Every little sound counts, and each detection of a neutrino is a cause for celebration in the scientific community. However, it's not all that simple. Most of the neutrinos that reach us come from the sun. But there are also other sources such as supernova explosions or black holes. This means that detectors must be able to differentiate between different types of neutrinos. Imagine being at a festival where thousands of people are shouting and having fun, and you need to find your friend in the crowd. It requires patience and a good strategy. And what about the number of neutrinos that pass through us every second? It is estimated that trillions of neutrinos pass through your body in a single second without you even noticing. It's a daily experience that we cannot perceive, but it invites us to reflect on the nature of matter and the forces at work in our universe. The study of neutrinos has also taught us about the behavior of matter under extreme conditions. For example, it has been shown that neutrinos can oscillate, meaning they can change from one type to another while traveling. This phenomenon is not only fascinating but also raises profound questions about the nature of the universe. What does this mean for our understanding of how everything works? Furthermore, research on neutrinos has allowed scientists to make advances in fields such as cosmology and particle physics. As we better understand how to detect and study these particles, we can also gain clues about the mysteries of the universe, such as dark matter and antimatter. It's like opening an ancient book and discovering that the pages are filled with secrets waiting to be revealed. Each new neutrino detection experiment fuels scientific curiosity. What discoveries can be made in the future? With ongoing projects and new technologies, researchers are constantly pushing the boundaries of what we know. Neutrino detection is an evolving field that promises to reveal even more about the secrets of the cosmos. The challenges are great, but the drive to uncover the truth is even greater. Neutrino research is not just a quest for knowledge. It is an exploration of the very foundations of our existence. Each small advance brings us one step closer to understanding the universe we live in. So the next time you think about neutrinos, remember that they are more than just simple particles. They are messengers from the cosmos, passing through everything in their path, and despite their elusive nature, they are deeply connected to the biggest questions in science. The hunt for these subatomic ghosts continues, and each detection is a new step toward understanding the mysteries of the universe. What if I told you that neutrinos are like ghosts of the universe? They travel through matter without being stopped, and therefore they can pass through the Earth as if it didn't exist. This sounds incredible, right? But that's precisely what they do. Neutrinos are subatomic particles that can change from one type to another as they move. This phenomenon is known as neutrino oscillation, and it is one of the most fascinating characteristics of these particles. Imagine you are at a concert and suddenly the music changes from one genre to another, but you continue enjoying the rhythm. That's how neutrinos work. They can change their melody while traversing the universe. There are three types of neutrinos: the electron neutrino, the muon neutrino, and the tau neutrino. Each of them is associated with a corresponding charged particle. But here's the intriguing part. When a neutrino moves, it can transform from one type to another. This happens due to the mixing of its properties, and it is a phenomenon that has puzzled scientists for decades. Neutrino oscillation is not just a cosmic magic trick. This phenomenon has profound implications for our understanding of the universe. For example, if we had a neutrino that transforms from one type to another while traveling, it could help us understand why there is more matter than antimatter in the universe. Isn't it amazing to think that something so small can have such a significant impact on the structure of the cosmos? Now, why is it so difficult to detect these changes? This is where their elusive nature comes into play. Neutrinos interact very weakly with matter. In fact, millions of them pass through your body every second without you noticing. Because of this, scientists must employ very advanced technologies to try to detect them. One of the methods involves using enormous tanks of water or ice that allow for the observation of the small interactions that occur when a neutrino collides with another type of particle. Neutrino oscillation is also related to the concept of mass. Modern theories suggest that neutrinos have mass, even if it is extremely small. This discovery has led scientists to rethink fundamental aspects of particle physics and the Standard Model. If neutrinos have mass, what does that mean for our theories about the universe? This is where scientific curiosity becomes even more fascinating. Thinking of neutrinos as a cosmic puzzle can be helpful. Each piece, each type of neutrino, plays a role in the big picture of the universe. Neutrino oscillation is like some of those pieces changing shape or color, which can alter how they fit into the overall landscape. This ability to change shape is what makes neutrinos so intriguing to researchers. The physics behind neutrino oscillation is an active field of research. For years, scientists have been collecting data to better understand how and why these transformations occur. Observing these oscillations has allowed for the detection of different types of neutrinos arriving on Earth from the Sun and other cosmic sources. As we advance in this field, new questions arise. How many types of neutrinos really exist? What are their exact properties? As we explore more about neutrino oscillation, another interesting question arises. Could neutrinos be a key to understanding dark matter? This form of matter, which makes up a large part of the universe, does not interact with light and is invisible. Some scientists suggest that neutrinos may play a role in the composition of this mysterious matter. The idea that such small particles could influence what we see and do not see in the universe is mind-boggling. Furthermore, neutrino oscillation offers us a window into the past of the universe. Neutrinos are generated by extremely energetic processes, such as supernova explosions. When these neutrinos reach Earth, they bring us information about events that occurred thousands or even millions of years ago. Imagine being able to hear the history of the universe through these tiny particles, as if they were messengers from the past. Experiments on neutrino oscillation have also become a kind of scientific race. Different groups of researchers around the world are working in underground facilities and ice experiments in search of answers. Each new discovery raises more questions, keeping the spark of scientific curiosity alive. What other secrets will these particles reveal to us in the future? One of the most exciting aspects of neutrino oscillation is that it represents a bridge between particle physics and cosmology. The way neutrinos interact in the universe can provide clues about its evolution. How do they influence the formation of galaxies or the distribution of matter in the cosmos? This is an area of study that continues to evolve and promises surprising discoveries. In summary, neutrino oscillation is a fascinating phenomenon that not only challenges our ideas about physics, but also opens doors to new questions about the universe. These tiny subatomic ghosts, which can change shape as they travel, are a key piece in the puzzle of existence. As we continue to investigate, the hope is that we can unravel the mysteries surrounding these elusive travelers of the cosmos. In this journey, neutrinos are not just protagonists. They are silent witnesses to the history of the universe. Neutrinos, those tiny particles that seem to escape the notice of scientists, have a fascinating role that is often overlooked. But did you know they are intrinsically related to antimatter? Antimatter is a concept that sounds like science fiction, but in reality, it is a fundamental part of the universe we inhabit. How are neutrinos linked to this cosmic enigma? To understand this relationship, we must first remember that antimatter is like a mirror of the world we know. Instead of electrons, protons, and neutrons, antimatter is composed of positrons, antiprotons, and antineutrons. When a particle of matter and a particle of antimatter meet, they annihilate each other, releasing a tremendous amount of energy. This phenomenon is not just a scientific curiosity, it has profound implications for the nature of the universe. Now, neutrinos are extremely light and elusive particles. There are three types of neutrinos, each associated with a particle of matter: the electron neutrino, the muon neutrino, and the tau neutrino. And what does this have to do with antimatter? The key lies in how they behave in fundamental interactions. In the world of particles, symmetry is an essential principle. However, in the case of neutrinos, things get complicated. Experiments have shown that neutrinos have an intriguing property called CP violation, which refers to the difference in behavior between matter and antimatter. In simple terms, this means that neutrinos behave differently from their antiparticles, the antineutrinos. This difference could be a crucial clue to understanding why there is more matter than antimatter in the universe. Can you imagine a universe where antimatter was as abundant as matter? Perhaps we wouldn't be here to tell the tale. Many scientists believe that this asymmetry could be the reason why the universe is as we know it today. If there had been an equal amount of matter and antimatter at the beginning of the universe, they would have annihilated each other, leaving only energy. But why is there a preference for matter? This is where neutrinos play a fundamental role. By studying their properties, physicists are trying to unravel this mystery. One fascinating aspect of neutrinos is their ability to change type as they travel. This phenomenon, known as neutrino oscillation, is another clue about their nature and their relationship with antimatter. As neutrinos travel from the Sun to Earth, they can transform from one type to another. This behavior is not only intriguing but also suggests that the physics behind neutrinos is more complex than we imagine. To better understand this connection, scientists conduct experiments in underground laboratories and particle accelerators. They seek answers to questions like, why do neutrinos seem to have mass even though they are so light? What does this mean for antimatter? Each discovery in this field adds another piece to the cosmic puzzle. Neutrinos could also provide clues about dark energy and dark matter. While the matter we know makes up only a fraction of the universe, the rest is composed of these mysterious entities. By exploring how neutrinos interact with matter and antimatter, scientists could shed light on these abstract concepts. But studying neutrinos is not easy. Because they are so elusive, detecting them is a significant challenge. Most of them pass through the Earth without being affected by the matter they encounter. This makes experiments complicated and costly. But the reward of understanding their connection to antimatter is worth the investment. This search also leads us to the question of the existence of more dimensions. Some theories suggest that neutrinos could be connected to hidden dimensions that we cannot perceive. If this were true, it could explain some of the strange properties of neutrinos and their relationship with antimatter. Could we be on the brink of discovering a new chapter in the history of physics? As we advance in research, the relationship between neutrinos and antimatter remains a hot topic. Each new finding in this field brings us closer to understanding the fundamentals of the universe. Neutrinos, though tiny, could hold the answers to existential questions about our own existence. Finally, it is important to highlight that the study of neutrinos and their connection to antimatter is not only relevant to physics. It also raises questions about life itself and our understanding of the cosmos. As we explore this intriguing link further, we are not only unraveling the secrets of the universe but also our own story within it. So as we look at the stars, let us remember that each twinkle could be related to these tiny messengers of the cosmos. What else will neutrinos reveal to us in the future? Only time and ongoing research will continue to unveil their secrets. And we will be here to follow the thread of this fascinating story. Neutrinos, those tiny particles that wander through the universe, play a crucial role in cosmology. But how do these almost invisible particles influence the formation and evolution of the cosmos? To understand this, we must first delve into the role they play in the most colossal events of the universe. When we talk about the formation of the universe, we often think of the Big Bang. At that moment, a colossal explosion of energy was created, which also gave rise to subatomic particles, including neutrinos. Can you imagine a primordial universe filled with a hot soup of particles? Amidst this mix, neutrinos began to form and travel through space almost unimpeded, thanks to their elusive nature. In fact, it is estimated that billions of neutrinos pass through our bodies every second without us noticing. As the universe expanded and cooled, these neutrinos began to interact with other particles in very specific ways. But why are they so important? The answer lies in their ability to provide information about the state of the universe in its early stages. By studying neutrinos, scientists can unravel secrets about the matter and energy that existed right after the Big Bang. The journey of neutrinos doesn't stop there. In the life cycle of stars, these particles play a fundamental role. When a star reaches the end of its life and explodes in a supernova, enormous amounts of neutrinos are produced. Hundreds of trillions of them can be released in a matter of seconds. This rain of neutrinos can travel through space and reach Earth, where detectors are ready to collect that information. It's as if neutrinos are messengers from the universe, telling us stories about distant events. But let's talk about dark matter. This cosmic enigma represents almost 85% of the matter in the universe, and although we cannot see it, its influence is undeniable. Some theories suggest that neutrinos, due to their light nature and weak interaction, could be a component of this mysterious dark matter. Imagine neutrinos as shadows that, although we cannot see, affect what happens around us. If we are correct, understanding neutrinos could be key to unraveling the mystery of dark matter. As we explore how neutrinos influence the evolution of the universe, it becomes evident that their existence is intertwined with the very history of the cosmos. From the Big Bang to supernova explosions, neutrinos are silent witnesses that help us reconstruct the timeline of the universe. Without these small but important actors, our understanding of cosmic history would be incomplete. Moreover, neutrinos are essential for the balance of the universe. Through their interactions with other particles, they help regulate fundamental processes that shape the structure of the cosmos. For example, their role in nuclear reactions within stars is critical for producing the elements that make up everything we see around us. Without neutrinos, life as we know it could not exist. An intriguing question is, what would happen if neutrinos did not exist? If these particles had not been part of cosmic history, the universe would be a radically different place. Stars might have had shorter life cycles, the process of element formation could have been altered, and ultimately, life on Earth itself might not have emerged. It's astonishing to think about how something so small can have such a large impact. In the realm of cosmology, neutrinos also offer us clues about the accelerated expansion of the universe. Some theories suggest that dark energy, which drives this acceleration, could be related to the properties of neutrinos. As scientists continue to explore these connections, new avenues of research open up that could rewrite our understanding of the cosmos. Furthermore, as neutrino detectors become more sophisticated, the data collected can provide insights into the past and future of the universe. Each detection is like a piece of a cosmic puzzle that, when assembled, can reveal a more complete picture of the universe's evolution. The combination of theory and practice in this field is fascinating and promises even more surprising discoveries. The study of neutrinos also raises ethical and philosophical questions. If we better understand how they work and how they influence the cosmos, what implications does that have for our own existence? Science and philosophy often intersect in these types of discussions, and neutrinos are an excellent example of how scientific research can challenge our beliefs and expand our worldview. In summary, neutrinos are much more than mere particles. They are messengers of the universe that tell us stories about its formation, evolution, and structure. Their impact on cosmology is profound, and as we continue to investigate, we are likely to uncover even more secrets that help us understand our place in the vast cosmos. Research on neutrinos is vital for unraveling the mysteries of the universe and, at the same time, for reflecting on our own existence within it. So the next time you hear about neutrinos, remember that these tiny particles are at the heart of some of the biggest questions humanity has ever asked. Neutrinos have been the subject of fascination and mystery in the world of physics, but how do they relate to something as elusive as dark matter? To understand this, we must first remember that dark matter is one of the great unknowns of the universe. Although we cannot see it directly, we know it is there because it influences the way galaxies move and cluster. But what role could neutrinos play in this cosmic puzzle? Neutrinos are particles that barely interact with matter. They are so light that, if we compare them to other particles, they would be like a mosquito flying in a storm. Their minimal interaction with the rest of matter means they can pass through planets, stars, and ultimately the entire universe without being detected. This raises an intriguing question. If neutrinos are so abundant and difficult to catch, could they be part of the solution to the mysterious nature of dark matter? One of the most interesting theories suggests that neutrinos could contribute to the mass of dark matter. Imagine that dark matter is a deep, dark ocean. In this ocean, neutrinos would be like tiny bubbles that, although invisible, add a layer of complexity to the surface. This idea comes from the observation that the number of neutrinos generated in astrophysical events could be large enough to influence the total mass of the universe. On the other hand, scientists have been studying how neutrinos behave in relation to gravity. Since neutrinos have mass, albeit extremely small, they can be attracted by the gravity of galaxies and other celestial bodies. This raises another fascinating question. If neutrinos cluster in certain regions of the universe, could they be forming structures of dark matter without us being able to see them directly? Some theories suggest that neutrinos could form a type of cloud that extends throughout the universe, influencing the formation of galaxies and galactic clusters. Just as air can be invisible but still affects the movement of a boat in water, neutrinos, although difficult to detect, could be playing a crucial role in the fabric of the cosmos. But how can we prove this is true? Current experiments are designed to delve into this connection between neutrinos and dark matter. Technologies are being developed that will allow us to measure the abundance of neutrinos in different regions of the universe and analyze how they are distributed. This is similar to trying to track the flow of an underground river. Although you can't see it, you can discover its presence through the effects it has on the landscape. One of the most intriguing proposals is the idea that neutrinos could interact with other dark matter particles, forming an ecosystem of particles that feed back into each other. This interaction could be so subtle that it might go unnoticed in most experiments, but with the right technology, we could begin to glimpse these hidden connections. Some scientists believe that neutrinos are the key to unraveling the enigma of symmetry in the universe. Currently, we know that there is more matter than antimatter, but we do not have a complete explanation of why this occurs. Since neutrinos have unique properties that distinguish them from other particles, they could be a crucial element in understanding this asymmetry. Could neutrinos be the missing link that helps us understand why our universe is the way it is? The search for answers does not stop here. Neutrinos are also key players in the study of the fundamental forces of nature. Their behavior can provide clues about how particles relate to each other in the universe, which in turn could shed light on the nature of dark matter. Research in this field is constantly evolving, and each discovery opens new doors to even deeper questions. As we advance in our understanding of neutrinos, it is essential to continue exploring their mysteries. Research on these particles could not only help us understand dark matter, but also unravel other cosmic enigmas. In the future, we could explore theories that connect neutrinos with other astrophysical phenomena, expanding our understanding of physics and cosmology. Reflecting on the role of neutrinos in dark matter is like looking through a fogged-up glass. As we clean the surface, we begin to see more clearly what lies behind. Each new finding brings us a little closer to the truth about the universe and its composition. The quest for answers about neutrinos and their relationship with dark matter is an exciting journey that we are just beginning to explore. Finally, we cannot forget that research on neutrinos is a global effort. Scientists from around the world collaborate on projects aimed at unraveling these mysteries. This scientific community is united by curiosity and the desire to understand the universe, reminding us that although neutrinos are elusive, our determination to comprehend them is unwavering. So as we continue to seek answers, each neutrino we detect brings us one step closer to understanding not only dark matter, but also the vast and enigmatic universe we inhabit. In the vast universe of physics, there is an enigma that has fascinated scientists and curious minds alike. What secrets do neutrinos reveal about the very nature of reality? These particles, practically invisible and extremely elusive, may offer clues about what happens beyond what we know. But why are they so important in the quest for answers to fundamental questions in physics? Neutrinos, those tiny cosmic messengers, seem to be part of a larger story. In the standard model of particle physics, which describes fundamental particles and their interactions, neutrinos hold a special place. However, they are often overlooked, like those stars that shine in the sky but are not visible to the naked eye. What if I told you that these tiny travelers could have profound implications for our understanding of the universe? One of the most intriguing questions that arises is, could neutrinos be related to phenomena that we have yet to explain? For example, dark matter. We know that dark matter makes up a large part of the universe, but we do not know exactly what it is. Some scientists suggest that neutrinos could be one of the keys to unraveling this mystery. Can you imagine that these particles, so difficult to detect, might be linked to something as grand as the structure of the cosmos? The idea that neutrinos could help extend the standard model is fascinating. This model has been the foundation of our understanding of physics for decades, but it also has its limitations. There are unanswered questions such as the nature of gravity or the asymmetry between matter and antimatter. In this context, neutrinos could open new avenues of research. What if, by studying their properties, we could discover new physics that challenges what we know? It is interesting to think that neutrinos have mass, even if it is extremely small. This characteristic has led scientists to speculate about new theories that could include yet undiscovered particles. What if there are other dimensions or new types of interactions that we cannot yet imagine? Neutrinos could be the gateway to exploring these ideas. The search for a theory that unifies all the forces of nature has been a dream for many physicists. Along this path, neutrinos could play a crucial role, acting as indicators of phenomena that we have not yet been able to observe directly. Imagine that by studying how they behave, we could find a connection between quantum physics and gravity, two pillars that have so far kept their distance. We cannot forget the question of symmetry in the universe. Why is there more matter than antimatter? Neutrinos, in their quest to interact differently with matter and antimatter, could be a key clue to solving this puzzle. Some theories suggest that their behavior could be the reason behind the predominance of matter in our universe. Is it possible that these particles are the protagonists in a story we have yet to fully tell? Some scientists propose that research on neutrinos could revolutionize our understanding of particle physics. Imagine a future where we can detect new particles or phenomena that challenge the laws we have established. This future is not so far off, as many current experiments are designed to seek precisely that. Who knows what discoveries the next decade holds for us? Neutrinos also invite us to rethink the way we understand energy and matter. As we explore their properties, we might discover that reality is even stranger than we think. The idea that these particles could have an impact on dark matter, on the evolution of the universe, or on the very structure of matter leads us to ask, how many more surprises await us on this journey? As we delve into these mysteries, it is essential to remember that the study of neutrinos is not just for theoretical physicists. Understanding these phenomena could have implications for technologies we have yet to imagine. From energy to quantum computing, the effects of neutrinos could ultimately transform our daily lives. In this context, international collaboration is crucial. Scientists from around the world work together to build facilities and experiments that seek to unravel the secrets of neutrinos. The scientific community comes together in a collective effort, demonstrating that knowledge knows no borders. Who knows what discoveries will arise from this global collaboration? In summary, neutrinos are more than just simple particles. They are a window into a universe full of mysteries. As we explore their nature and their relationship with dark matter, gravity, and other fundamental forces, we move closer to a more complete understanding of reality. In the end, every small discovery about neutrinos could be a step toward revealing the secrets of the universe. Science is an endless journey, and neutrinos are one of the many paths we can explore. Every question that arises leads us to new answers, and every answer opens the door to more questions. Are you ready to continue this journey and discover what neutrinos have to offer? In the vast ocean of the cosmos, where stars shine and planets spin, there is a type of particle that travels almost unseen but plays a fundamental role in the history of life on Earth: neutrinos. What connection can these elusive particles have with the evolution of our planet and, ultimately, with ourselves? The answer is more intriguing than you might imagine. Neutrinos are like shadows gliding through the universe. They are produced in a variety of cosmic processes, from supernova explosions to nuclear reactions in our own sun. But why are they so important for life on Earth? The answer lies in their ability to interact with matter in ways we are just beginning to understand. Throughout history, neutrinos have been silent witnesses to cosmic events. For example, when the sun generates energy through nuclear fusion, it produces a torrent of neutrinos that travel to Earth. Every second, billions of these tiny messengers pass through our bodies without us noticing. But how can these particles, which barely interact with matter, have an impact on life on our planet? The key lies in their abundance and nature. Neutrinos are extremely numerous. It is estimated that trillions of them pass through us every day. Although they do not interact significantly with matter, their constant presence means that deep down they are intertwined with the history of life on Earth. Could it be that their influence, though subtle, has contributed to the evolution of species? Let's think of it another way. Imagine that neutrinos are like the wind blowing through a forest. You cannot see the wind, but you know it is there because it moves the leaves and makes the trees sway. Similarly, neutrinos may have had an effect on the chemistry of our planet, influencing the nuclear reactions that sustain life. In recent years, scientists have begun to explore how neutrinos might have played a role in the creation of heavy elements in the universe. These elements are fundamental to life as we know it. Without the elements formed in stars and then scattered into space, Earth would not have the necessary components to host life. So, could neutrinos be part of this cosmic story? Moreover, neutrinos are also involved in processes that affect the atmosphere of our planet. Interactions between neutrinos and other atmospheric components could influence cloud formation and, consequently, the climate. So, even though we do not see them, their presence may be shaping the environment in which we live. Isn't it fascinating to think that these almost invisible particles can have such a significant impact? On the other hand, neutrinos not only influence us as living beings, but they also tell us a story about our past. By studying the neutrinos that reach Earth, scientists can gain clues about events that occurred in the universe billions of years ago. This allows us to better understand how life developed on our planet. What secrets could these tiny particles reveal about our ancestors? In this sense, neutrinos are like the messengers of the universe. Through them, we can look back in time and discover how not only stars and galaxies have formed and evolved, but also life on Earth. Every neutrino that passes through us is a reminder that we are part of something much larger. As research progresses, scientists are beginning to make deeper connections between neutrinos and biology. For example, some studies suggest that neutrinos could be related to how cells respond to certain stimuli. Could it be that these particles influence how life adapts and evolves? Ongoing experiments are seeking to better understand this relationship. What other mysteries could neutrinos unveil about life on Earth? The possibilities are exciting, and as technology advances, new doors open to discover more. So, the next time you look at the starry sky, remember that there is much more happening around you than it seems. Neutrinos, though invisible, are an integral part of the story of our universe and our own existence. Every tiny flash of energy in the cosmos, every explosion of a distant star, is connected to us through these elusive particles. In conclusion, neutrinos are much more than simple particles. They are witnesses of the past and bearers of crucial information about how life on Earth came to be. Research into their influence on our evolution is just the beginning of an exciting journey toward understanding our place in the vast universe. So let's keep exploring, because the secrets that neutrinos reveal to us are just the beginning of a great scientific adventure. What if I told you that neutrinos, those almost invisible particles, can reveal secrets about the universe that we have yet to discover? Imagine a world where these tiny cosmic messengers could change our understanding of matter, energy, and the very fabric of the universe. In the next few minutes, we will explore the exciting experiments underway, designed to unravel the mysteries of neutrinos. Let's start with a fascinating fact. It is estimated that trillions of neutrinos pass through our bodies every second without us noticing. But what does it take to capture them or study their behavior? The answer lies in innovative projects that combine cutting-edge technology with humanity's innate curiosity to understand the unknown. Scientists are using underground facilities, ice laboratories, and even the ocean to try to detect these elusive particles. Why? Because every small discovery about neutrinos could have a monumental impact on our understanding of the universe. One of the most ambitious projects is the Dune experiment, which is being built in the United States. Here, a beam of neutrinos is planned to travel over 1,000 kilometers to reach a detector. Imagine a precision shot of 1,000 kilometers, where each neutrino is a small traveler carrying information about its origin. This experiment is expected to answer fundamental questions about matter and antimatter. How do neutrinos behave? Why is there more matter than antimatter in the universe? Dune could provide us with crucial clues. In Japan, the Super Kamiokande experiment is located in a zinc mine where thousands of tons of purified water act as a giant detector. When a neutrino interacts with the water, it produces a detectable flash of light. This experiment has been operational for over 2 decades and has made significant discoveries, including the demonstration that neutrinos have mass. Who could imagine that a simple flash could change our understanding of physics? At the South Pole, the ice cube experiment is another example of how science seeks neutrinos. This detector, buried in Antarctic ice, looks for high-energy neutrinos that could come from extreme cosmic phenomena like black holes or supernovae. Just like a fisherman using a hook, scientists use sensors that detect the light generated by the interaction of neutrinos with the ice. What kind of cosmic secrets could be revealed thanks to this experiment? Researchers are also looking for ways to build more sensitive and efficient detectors. Imagine a world where we can detect even the weakest neutrinos. One of the promising technologies is the use of advanced materials that can amplify the signal of neutrinos. This could open new doors in our quest to understand not only neutrinos, but also fundamental aspects of the universe that remain a mystery. Have you ever wondered what other experiments might be on the horizon? One example is the NEXT experiment, which focuses on neutrinos produced in beta decay reactions. This experiment could shed light on the nature of neutrinos and their relationship with dark matter. The connection between these two concepts could be the key to understanding the structure of the universe. International collaboration also plays a crucial role in neutrino research. Scientists from around the world come together in projects like the T2K experiment in Japan and the Sudbury Neutrino Observatory in Canada. This global cooperation allows for the sharing of knowledge and resources, thus advancing our collective understanding. What discoveries could arise from these international collaborations? The ongoing experiments are not only designed to answer questions but also generate new ones. How are neutrinos related to dark energy? Could they be part of a new paradigm in our understanding of physics? Each answer leads to new questions, and that is how science progresses. As we move forward in time and technology, it is likely that neutrino detection will become more common in scientific research. With the development of new detectors and methods, the possibility of discovering new phenomena could be closer than we think. What will happen when we manage to capture the signal of a neutrino of unknown origin? As we reflect on these future experiments, it is essential to remember that curiosity and the desire to understand our surroundings are the driving forces of science. Every small advance in neutrino detection not only brings us closer to unveiling the secrets of the cosmos, but also invites us to question our place in the universe. The story of neutrinos is a tale of perseverance and discovery. From their humble beginnings to today's high-tech experiments, each step has been a testament to human ingenuity. What other mysteries await us along the way? The answer could be just around the corner. waiting to be uncovered by the next generation of scientists. As we reach the end of this exploration of the future of neutrinos, it is clear that the journey has only just begun. The ideas and theories that will emerge from these experiments could change our understanding of physics, cosmology, and perhaps even the very nature of reality. The search for neutrinos is an exciting journey, full of surprises and possibilities. Are you ready to join this cosmic adventure? Neutrinos, those tiny particles that barely interact with matter, have found their place in popular culture through science fiction and other forms of artistic expression. But have you ever stopped to think about how these almost invisible particles have captured the imagination of writers, filmmakers, and even artists? Human curiosity about the unknown has led many to explore advanced physics concepts in their works, and neutrinos are a great example of this in various movies and television series. Neutrinos are often portrayed as mystical elements or as the key to unlocking the secrets of the universe. Imagine a plot where a scientist discovers that neutrinos are the means of communication between dimensions. This idea, while fantastic, resonates with the reality that neutrinos are messengers of the cosmos, traveling vast distances without being stopped. Isn't it intriguing to think that these particles are constantly passing through our bodies and the planet without us realizing it? In cinema, science fiction films like Interstellar have explored the mysteries of the universe, and although they do not specifically focus on neutrinos, they address concepts that touch on particle physics. The idea that there are forces and particles beyond our usual understanding invites us to reflect on what we really know about the universe. How many stories have yet to be told because we do not fully understand the role of neutrinos in the formation of stars and galaxies? The series The Big Bang Theory, although presented in a comedic format, has sparked interest in particle physics, including neutrinos. The way the characters discuss complex topics humorously makes difficult concepts more accessible to the audience. Who would have thought that a conversation about neutrinos could generate so many laughs while simultaneously sparking interest in science? In addition to movies and series, neutrinos have also made their way into video games. In science fiction titles, they are often depicted as energy or as part of futuristic technology. Players may encounter devices that use neutrinos to travel through space or to unlock special abilities. This raises a fascinating question. How much of what we see in these virtual worlds reflects our curiosity about real physics? Science fiction novels have also been infused with ideas about neutrinos. Authors like Arthur C. Clarke and Isaac Asimov have explored concepts that, while fictional, are inspired by real science. In their stories, neutrinos often represent the boundary between the known and the unknown, pushing us to question our place in the universe. Were these writers anticipating discoveries that had yet to be made in their time? In the realm of science communication, many YouTubers and content creators have begun to use neutrinos as a central theme to educate their audiences. With enthusiasm and creativity, they present these complex concepts in ways that are easy to understand and follow. The question is, how can we continue to use these platforms to inspire the next generation of scientists and dreamers? Neutrinos have also been the subject of documentaries that explore their nature and importance in the cosmos. These productions not only inform but also excite, leading us to contemplate the vast universe around us and the role these particles play in it. What other wonders of the universe are waiting to be discovered through the study of neutrinos? In popular culture, neutrinos can also symbolize what we cannot see. Often what is invisible is the most powerful. This applies both in science and in everyday life. Emotions, thoughts, and human connections are equally invisible but profoundly real. Could it be that by exploring the mysteries of neutrinos, we are also exploring something deeper about ourselves? Neutrinos, though elusive, teach us that the universe is full of surprises. In every corner of the cosmos, there are stories to tell, and particles like neutrinos are often the protagonists of these narratives. What other secrets of the universe could be revealed if we only dare to look beyond what we can see? In summary, neutrinos are not only a fascinating part of particle physics, but have also found their home in our popular culture. From movies to video games, these particles have inspired stories that invite us to dream, question, and explore. In a world where science and fiction often intertwine, neutrinos stand as a reminder that human curiosity knows no bounds. Who knows what discoveries or narratives are yet to come? What if I told you that neutrinos, those almost invisible particles, are key to unraveling the secrets of the universe? It may seem surprising, but in the vast cosmos, these tiny messengers can offer clues about the very nature of matter, energy, and even life. But why should we care about studying neutrinos? The answer is as fascinating as the neutrinos themselves. First, neutrinos are like shadows that traverse the universe. Despite being incredibly abundant, they are extremely difficult to detect. They are produced in cosmic processes such as supernova explosions or reactions in the sun's core. Every second, billions of neutrinos pass through us, but unlike other particles, they barely interact with matter. This raises an intriguing question. What secrets do these silent and elusive particles carry? Investigating neutrinos is like trying to solve a giant puzzle. Each discovery about them helps us better understand how the universe works. For example, did you know that the existence of neutrinos could explain why there is more matter than antimatter in the universe? By studying these particles, scientists seek to unravel the mystery of asymmetry in the cosmos. Every answer we find brings us closer to understanding the history of how stars, planets, and ultimately life itself formed. The study of neutrinos also impacts our understanding of the evolution of the universe. Imagine that each neutrino we detect is like a small window into the past, revealing information about events that occurred billions of years ago. Thus, by investigating these particles, we are not only looking at the present but also at the past, gaining a unique insight into cosmic history. We cannot forget that neutrinos are also related to some of the most extreme phenomena in the universe, such as black holes and supernova explosions. By understanding how neutrinos are generated and behave in these events, we can improve our theories about fundamental physics. Who wouldn't want to know more about what happens in the heart of a supernova? Another reason to study neutrinos is their potential to help us decipher one of the greatest mysteries of cosmology: dark matter. Although we know that this mysterious substance makes up most of the universe, we have yet to detect it directly. Some scientists believe that neutrinos could be related to it, which would mean that by better understanding neutrinos, we could take a step toward identifying dark matter. Moreover, research on neutrinos is constantly evolving. Neutrino detection experiments are at the forefront of modern physics, using innovative technologies to explore these mysteries. From detectors in the ice of Antarctica to underground facilities, the amount of information we are gathering is astounding. Each new experiment offers us an opportunity to expand our knowledge and challenge our existing beliefs. But is all this just science for the sake of science? No, neutrino research has practical implications. Advances in this area could lead to new technologies and applications in fields as diverse as medicine and energy. For example, developing more effective methods for neutrino detection could inspire new medical imaging techniques. Thus, what we learn about neutrinos could have a direct impact on our daily lives. However, not everything is straightforward. Neutrino research faces significant challenges. Detecting these particles is technically complicated and requires resources and international collaboration. But every obstacle we overcome on this path also brings us closer to the truth about the universe and our existence within it. The question that remains is, are we ready to move forward with this exciting exploration? The study of neutrinos invites us to be curious, to question what we think we know, and to seek answers in the most unexpected places. Science is a journey, and neutrinos are a crucial part of that voyage. By following their trail, we can discover not only the secrets of the universe, but also our own. So the next time you hear about neutrinos, remember that they are not just tiny particles. They are carriers of information, messengers of the cosmos, and their study is essential for understanding the universe we live in. What other mysteries will be revealed as we delve deeper into the world of neutrinos? The answer could be more surprising than we ever imagined. The research on neutrinos is a path full of challenges that often seem insurmountable. But what makes this study so complicated? To begin with, neutrinos are extremely elusive. Imagine trying to catch smoke with your hands. That's similar to what scientists face when trying to detect these particles. Although they are abundant in the universe, neutrinos interact so weakly with matter that on average a neutrino can pass through the entire Earth without being detected. So how can they be studied? It's interesting to think about the number of neutrinos that surround us. Every second, trillions of them pass through our bodies. However, despite their abundance, they can only be detected using very advanced and specific technology. This raises an intriguing question. What kind of technologies are necessary to capture the presence of something so elusive? Experiments to detect neutrinos are often complex and require enormous facilities, such as underground tunnels and large tanks of water or ice. This means that resources and time are critical factors in this research. The first major difficulty lies in locating neutrinos. How can you study something that barely leaves a trace? Scientists use indirect methods to detect their presence. These methods include observing the interactions that neutrinos have with other types of particles. But what happens if those interactions are so rare that it takes a long time and effort to observe them? Often experiments can take years or even decades to provide meaningful results. Is this discouraging for researchers? Not necessarily. The scientific community is filled with passionate individuals who are willing to face these challenges. However, the scarcity of funding is a constant obstacle. Research in particle physics, and particularly in the study of neutrinos, can be very costly. How are these projects prioritized in a world where there are so many urgent needs? The answer to this question lies in the potential these studies have to revolutionize our understanding of the universe. Every small advance could open the door to new discoveries. International collaboration is another essential part of this research. But what's the challenge here? Coordinating scientists from different countries with different languages and cultures is not an easy task. Additionally, each country may have its own priorities and budget constraints. This can lead to tensions and logistical challenges that further complicate the research. How are these difficulties overcome? The answer lies in a shared commitment to science. Researchers often find ways to work together, sharing resources and knowledge. Despite the difficulties, collaboration can lead to amazing results. However, even when progress is made, new questions arise. For example, what do we do when our theoretical models do not match experimental results? This can be frustrating, but it is also a vital part of the scientific process. The constant change in technology also presents a challenge. The tools and methods for detecting neutrinos are continuously evolving. As new technologies are developed, researchers must adapt, which can sometimes delay projects. Isn't it amazing to think that what was considered cutting edge a few years ago can become obsolete so quickly? However, this evolution also creates opportunities. Each technological improvement can unlock new research avenues. Moreover, the very nature of neutrinos poses its own set of enigmas. There are different types of neutrinos, each with unique properties. This means that in practice, scientists not only have to detect one type of particle, but multiple ones. How is research organized to address this diversity? Each type of neutrino may require a different approach, adding an additional layer of complexity. The lack of data is also a significant challenge. Despite efforts, scientists often encounter a void of information. This can limit progress and understanding of how neutrinos fit into the larger puzzle of the universe. How are uncertainties managed in research? The answer lies in an open mindset and a willingness to accept that not all questions have immediate answers. Despite all these challenges, neutrino research is crucial. Understanding these particles could not only answer fundamental questions about the universe, but could also have practical applications in other areas, such as medicine and energy. Is the effort worth it? The answer is a resounding yes. Scientists pursue knowledge with the hope of making discoveries that change our perspective on the cosmos. Finally, it's important to remember that every small advance in neutrino research is a step forward in our understanding of the universe. Although the challenges are numerous and sometimes daunting, the perseverance and passion of researchers are what drive science forward. Isn't it inspiring to think that despite all these obstacles, human curiosity continues to seek answers in the shadows of the universe? The story of neutrinos is a story of challenge, collaboration, and above all, a deep desire to understand the world around us. The exploration of neutrinos, those tiny particles that traverse the universe unseen, leads us to a fascinating conclusion about the very nature of the cosmos. Throughout this journey, we have discovered how neutrinos are fundamental to understanding not only the inner workings of the Sun, but also the titanic explosions of supernovae and the mysteries of dark matter. But why is it so crucial to continue investigating these tiny messengers of the universe? The answer lies in the deep connection that neutrinos have with the laws governing the universe. Every time a neutrino is produced, whether in the core of a star or during a supernova explosion, it shares information about cosmic processes that we cannot observe directly. So what can we learn from them? The answer is simple: everything. From the formation of elements to the evolution of galaxies, every neutrino that reaches Earth is like a letter sent from the past of the universe, revealing secrets that have remained hidden for eons. Reflecting on the importance of neutrinos also leads us to question the history of science itself. How is it possible that something as elusive as a neutrino has challenged scientists for decades? The search for these particles has driven advancements in technology and inspired generations of researchers. Each experiment designed to detect neutrinos has been a step forward, not only in physics but in our understanding of the world around us. Moreover, research on neutrinos does not remain solely within the realm of particle physics. These tiny travelers also have implications for our understanding of life itself. Imagine that neutrinos, by interacting with matter on our planet, could have influenced the chemical processes that led to life as we know it. This opens up a completely new field of exploration, neutrinos as a thread connecting the cosmos and our existence. We cannot forget the role that neutrinos play in the search for answers to even bigger questions. What is dark matter? Why is there more antimatter than matter in the universe? The theories linking neutrinos to these enigmas are increasingly intriguing. Some believe that the answer to these great mysteries may be hidden in the properties and behaviors of neutrinos, making their study even more valuable. In a world where science is advancing by leaps and bounds, neutrinos stand out as an area of research that has the potential to revolutionize modern physics. Each discovery opens new doors and raises new questions. What will happen when we fully understand how neutrinos work? The possibility that they may lead us to a new era of discoveries is exciting and, at the same time, challenging. The future of neutrino research also promises to be bright. With innovative experiments underway and new detection methods, we are on the cusp of significant breakthroughs. Imagine a world where we can track these cosmic messengers with unprecedented precision. The information we gather could change our perception of physics and cosmology forever. However, not everything is easy on the path of neutrino research. The challenges are great, from the difficulty of detecting them to the need for advanced technologies. Each step in this research requires ingenuity and perseverance. But isn't that what has driven humanity to achieve great accomplishments throughout history? The quest for answers to the unknown has always been a motor of progress. The importance of studying neutrinos goes beyond pure science. It also speaks to our innate curiosity as human beings. Why is it essential to keep exploring? Because every answer we find through the study of neutrinos brings us a little closer to understanding our place in the universe. It reminds us that, although we are small compared to the vastness of the cosmos, our questions and discoveries have a significant impact. As we close this chapter on neutrinos, it is essential to remember that the knowledge we acquire is not just for scientists. Each discovery has the potential to inspire others, to open the minds of future generations, and to foster a culture of curiosity and exploration. Every detected neutrino is a reminder that there is still much to discover, and that each of us can be part of that search. So as we look to the future, the invitation is clear. Let us continue questioning, let us continue exploring, and let us continue learning. The story of neutrinos is still young, and who knows what new secrets they will reveal to us in the years to come. The adventure is just beginning, and we are all part of that story. Are you willing to follow the path of neutrinos and discover what else the universe has in store for us? The answer to that question may be more astonishing than you ever imagined.